Hello everyone, myself Ankit Shivare, and we are in the session 2 for IT SPICE simulations. So earlier we have done tutorial 1 session where we have discussed on the voltage divider and how to simulate. We have done DC operating point simulations, right? And we have seen the netlist. We have also seen how to set up the background and all these things, right? Cursor waveforms, etc. So in the second part, we are going to simulate a voltage control voltage source. So what is voltage control voltage source is, suppose you are applying a certain input voltage, the output voltage will be dependent on that input voltage. So suppose you are applying 2 volt input source, and suppose your voltage control voltage source gain is 2, so the output will be 4 volts. So it's like a multiplication in a way, right? So you are having some gain value and you are applying some input. So where this is used is like, suppose ideal op amp is there whose gain is 10 to the power of 6. So you are applying some 1 microvolt, so you will get the output in some volts, right? So it makes some sense, right? So you have some input which is of very low amplitude, you need to amplify it, okay? So in a way it's a voltage control voltage source. So we will do a simple simulation of voltage control voltage source. We will also do op amp and all these simulations later on, okay? So all these are the conceptual understandings that we are trying to do, right? So coming to the session, so first we will do the new schematic. I've done that already. Now I should save that schematic. So first is the save as option. So now this tutorial session will be named as tutorial_2, okay, and we should save it. So it will be in .asc format, okay. Now for the simulation we need a voltage control voltage source. You just go to the component and you go to the E and E2. So you will see, so suppose you see this is the voltage control voltage source. Now there is one more that is E2. So it's just a swap, so like negative positive, right? So the input is just swapped, so it's the same thing, okay, but with a different means representations, right? Different pins format, okay. So now you can have this voltage control voltage source and we can keep it here. Now this is the input side, so we need a voltage source. So let us have a voltage source. So a DC voltage source, the normal voltage source, that is voltage, and we will go OK, and we will place it here, okay. And we will need a resistor, RES. So resistors we will need. PQR, right? Yeah, this is the resistor, sorry. So our resistors is there, so we can do control R and just and control M is just the mirror. So suppose we do, it doesn't make a sense here. So when you are placing it, actually then you have to do, you can just go directly here and control R. So I need a 10 kilo ohms suppose resistor. So multiple times are done, so it's okay. And we need to have a ground, right? So ground, we can take one common ground or we can take 3 separate grounds for 3 different, doesn't make much difference. In the netlist I will show you that it will not make any difference here, okay. We should connect all these appropriately. So we will need a ground for this. Need to drag this one, okay, and I need one more ground. So this drag and move option are very best actually, and it's very comfortable actually, this LT SPICE. That's why I'm going with this LT SPICE. So spacebar you can fit your screen, so sometimes it may move. So just connect it back. A lot of connections are there. You can make all the ground to be same, okay, it doesn't matter. So now I need to set the DC voltage of this. So right click on this and you will get the option of DC value. I'm saying it is suppose 1 volt, okay, and I need to set the gain of this one, right? So it is asking me, so what is the value 1, value 2, the instance name. So you can see this is a prefix, that is E, and this is the instance name. So suppose I call second voltage control voltage source, the instance name will change E2, but the prefix will remain same, right? So it's a E, and the value of this I can set it, suppose I am saying I want a gain of 10. Okay, so it's okay. So I am getting a gain of 10 from here. Now I need to do a simulation, so I need to set up the DC operating point. So I can say just like .op and just plate it here, that's it. Okay, and just move this way. Now I should see the netlist first, right? So view, and I can go to the spice netlist, how it looks like. So you can see E1 is there with N002, this is the net, and 0, N001, 0, 10. So this is different 4 nets are connected, right? So 4 nets between N002, one is ground, then N001, and then 0, and the value of the gain is 10, right? Then V1 voltage source, again this N001, 2 nets, 0 and 1, the value is 1, R1 same way, the resistance are. I have not given that R value, so I should give that R value something, right? Makes some sense. Okay, so now this is done. Now I can label these nets, because I am seeing N001, N002, it becomes very difficult for me, right? So I can label them that like this is my input IN. Okay, so I can just place it here, and I can place another label stating that this is my output, right? This is my output. So now I suppose I see the netlist, view, and netlist. See here now, yeah. So this is out in. So V1 is between input and 0 and out 0. So it makes some sense, right? So these nets will define a netlist in a proper way. So you don't for the spice you don't need always this GUI window. You can just go in the command terminal and you understand. Then you can just directly type and do the simulations, right? It makes some sense. And I can add also comment also. So like I want to write like what is V out here is nothing but gain, that is gain times so gain times IN1 minus IN2. Okay, so I can write this comment. IN1 is nothing but this input and this input. So the difference between these two inputs multiplied by the gain, that is 10 here, will give you the output. That is how. This is my comment only. Okay, it is not any syntax or something. It is the comment I have given. Okay, you can delete that comment, no matter. Okay, for understanding I have just written that, and I can do the run. Let's see what goes up. Yeah, so now you can see the output, that is 10, and input is 1, IR1 is 1, IE1 is minus 1, and I1 is 1. So since the resistance, the voltage here is 10, so the current that will flow through the resistance is what? 1 ampere, correct? The current in the voltage source, this will be negative, right? Because the current is in the voltage source, when you see the current is going from the negative to the positive, and here it is going from positive to negative, right? So current is always from positive to negative in the device, right? So it is going negative to positive, so current is negative. Here positive to negative, so current is positive, right? And IE1 is minus 1, and IV1, because no current is being taken up, right? Voltage control voltage source means what? The current, input current is 0, so the input in resistance here is what? Infinity. So no current is there, it's ideal voltage source, right? So this is making some sense, right? So a voltage control voltage source is done. We can also do the same thing in the transient picture also, right? So we can have a transient simulation also for this case. So let us see how the transient simulation will look like. So I can go to control panel. Okay. So I need to set up the transient time simulation for this case. So for this I can go to view and edit spice directive. So now yeah, spice directive will come. So I want to go for the transient simulation, so I will write dot tran. Then the simulation step is 10 pico and I will go to 20 nano. So this is okay, and I can place it here, and can make a run. And let's see, a waveform GUI window will open. So I can see what is the voltage I want to measure, right? So I want to see the output. So output is 10 volts. Okay, now I can set the waveforms here also to different colors, right? So I don't want these colors. Okay, so it is asking me, so simulation tools, color preferences, and waveforms. I can say I want a white background. Sorry, this is for this one. I want for background this to be white, right? So I can do that. Apply. Okay, and I want axis to be perfectly black. Apply. Yeah, and now axis is black, and I want to see the traces with some red color. Yeah, so it is making some sense, right? So 10 volts. Now I can also do the voltages here, input. So this is 1 volt, right? So this is 1 volt, so this is 1 volt here. So I can just see the axis I can make it 12 volt, and bottom axis is 0 volt. Now I can do okay. Yeah, so this is 10 volts and this is 1 volt, the input signal. Okay, so I can also measure the current that is going through there, resistance R1. So in this axis you can see the current that is going is 10 amperes. So 1.0001 ampere, because 10 volts, right? So 10 by 10, 1 ampere. So this is 1 ampere that is current is going, right? This one. So this is the transient picture, because everything is DC here. So means I'm seeing all the DC values for all the transient time. So this transient time is in the x-axis, that is 0 to 20 nanoseconds. So hope this makes some sense. We will do further discussions on this in the next tutorial sessions. Thanks for your time.